let's monitor the campaign. Now that we've designed the campaign manager would like to understand if the campaign is going well or does it require any change. So this campaign was run for a week. It was run for only the existing customers, and every day the data was recorded. On day 2, the campaign manager reached out to us and asked us if we can measure and figure out how the campaign is doing, or is there any correction that is required. What was the information that is recorded every day is the response of the campaign. When we say response of the campaign, we are recording the number of orders that we are receiving based on the campaign. So what we already know is the probability of product P2, which was the product of our choice, being bought by online buyers and female buyers. So this is the prior probability that we already know, irrespective of the fact that the campaign is conducted or not conducted. So this is the prior probability that we have. Now, how can we help the campaign manager? We can help her by finding the posterior probability using Bayes theorem. Yes, this is a very interesting application of the Bayes theorem. Let's look how. So like I said, we already have the information in the prior probability. Prior probability of P of A, which is the event of our interest. Outcome number 2 and outcome number 5. Outcome number 2 was online buyers. Outcome number 5 was female buyers for product 2. So for this event of your interest, the probability that we had calculated in the previous probability table was 0.43. Now let us look at the data that was collected on the day 2. If we say that the data that was collected, the number of orders as the event B, the total responses that we had received was 185, and the orders that came from the existing customers was 180. Remember, this campaign was run. This campaign was sent only to our existing customers, the 838 customers. So out of those 838 customers, 180 people came back with an order request. Above and beyond, there were 5 more customers which were not really sent out the campaign, but they also came back, which is our first row, 185 customers, and the customers from our outreach base is 180 customers. Using this information, how can we calculate the posterior probability? Number 1, what would be the probability of event B? Event B would be 185 customers who reached out to us divided by the total number of customers who were outreached, 838. The probability comes out to be 0.22. What would be the probability of B and A, which is the customers whom we had reached and who came back with the order request? Probability of B and A would be 180 customers who came back with the order request divided by the total number of orders, 838. And finally, the conditional probability, the probability of event A, given that probability of event B is already known, would be 0.21 divided by 0.22, coming out to be 0.95. Using this information, we can calculate the posterior probability using the Bayes theorem. What does the Bayes rule say? It says that probability of event B given A is equal to probability of A given B multiplied by marginal probability of B divided by the marginal probability of A. Plugging in the numbers, we get 0.95 multiplied by 0.22 divided by 0.43, which is 0.449. So what does the posterior probability come out to be? 0.49. What was the prior probability? 0.43. What is the conclusion? The probability of the orders coming in from the customers has increased because of the campaign. So we can say that the campaign is doing well so far, nothing needs to be changed, and we can continue to monitor. The probability of responses is improved from 0.43 to 0.49, and as the posterior probability is improving, there is no need for any correction and we can continue to monitor the campaign.